Abrasive flow machining, or AFM, is an advanced finishing process in which difficult to reach surfaces, holes, edges, etc. are polished or deburred by flowing an abrasive laden viscoplastic polymer. The common abrasives are aluminum oxide, silicon carbide, boron carbide, diamonds, and these abrasives are mixed in a polymeric medium which is known as viscoelastic polymer, which is a high viscous fluid. It shows change in viscosity when under pressure. In the mechanism of AFM, the abrasive laden viscoelastic polymer is extruded through the hole on the workpiece, either in single direction or in two direction with high pressure. The pressure exerts an axial force and a radial force in this direction over the abrasive, which results into rubbing over the workpiece, which leads to microchip formations. The AFM process is classified into one-way, two-way, and orbital. The one-way AFM is the faster and simplest of all the methods, and in this the medium is pushed through one side of the workpiece. Here it is the workpiece, and this is the mechanism tooling used for pushing the medium. So the medium is extruded, that is pushed from one side of the workpiece, and it is free to go out through this direction. The two-way AFM is the most widely used method, and in which it employs two vertically opposed cylinders. So one is known as upper medium cylinder, that is the cylinder meant for medium, containing the medium, that is extrusion medium or abrasive medium, and this one is the upper medium cylinder, and similarly we have got a lower medium cylinder, and two pistons are also employed for pressurizing, and these pistons are simultaneously either moving upward or downward directions. While moving the piston in upward direction and downward direction, it also carries the abrasive medium in upward direction and in the lower direction. And while it is moving, it is extruded through the workpieces, and it is directed to the workpieces through this tooling, and this tooling is used for directing the abrasive particles through the workpiece. So since the abrasive particles are moving up and down through the workpiece, it provides the machining, required machining operation. The orbital AFM is used for surface and edge finishing applications. Here also a to and fro movement of the abrasive medium is provided, just like in two-way method with the help of two cylinders. In addition to that, we are providing an orbital vibration, that is a low amplitude orbital vibration to the workpiece for effective machining. The process parameters in AFM are grouped under machine parameters, abrasive parameters, and workpiece parameters. The application of AFM can be seen in aerospace industry, automotive industry, dies and mold industry, and in medical industry. Thanks for watching.